Hey guys, Mr. Bowman here. In today's video, we've got a word that I don't know how to pronounce. It's actually a Dutch scientist's last name, and he's developed an algorithm to help us to determine the shortest path in a network. And I'll show you what I mean by shortest path. So that refers to the quickest way to navigate between 2 points. Quickest path to navigate, I've spelled navigate wrong. Navigate between 2 paths. And when we refer to quickest, we do refer to the weight. And just a reminder, the weight is the numbers attached to the edge of each of the networks. So why this is an algorithm and why this is a really good way to do it is a very systematic way to step through a network, and it lets you very precisely figure out the quickest way to get to every network. So the really good thing about this one here is it considers every possible route that you could take to navigate between those two points. So let's look into an example. Let's say we're at point A and we are trying to get to point F. What is the quickest way for us to get there? So we're going to go from point A to F, and what we're going to do is we're going to start off with, so we don't need to consider A because that's where we're starting, but if we go from A to C, it would have taken us 2 units long, and I'm going to call it A2 because we went from A, which means the one above, if we go this direction here, that's going to be A4 because we went from A and we've moved up to 4. So let's call that one there A4. And I now can cross out this path and this path because I've considered the 2 there, I've considered the 4 there. So let's consider this path here. So if I'm at B, I've currently traveled 4, which means plus the 5, that comes to 9. So I also could get to C via B, and that's called B9. And you see now that I've got 2 options, the quickest way to get to C is via A, which was 2, or I could have gone through B, which is 9. So what I'm going to do is I'm going to cross out B, because if I'm trying to get to C, it's quite clearly I need to go directly from A. And now I've considered that 5 there. Carrying on this way here, let's say we go from C to E. That there is plussing the 3, so that there would have been C5, because I've come from C, and plussing the extra 3 would have taken 5. I've now considered this route here. Along the top here, B to D, 10 units extra, so that's going to be 14. So this one here would be B14, and I'll cross this out. And then let's consider the 4 here. So to get this way to D, it took me 5 units to get here already. I've got an extra 4, which gets me to 9. So this one here is actually going to be E9. That's much quicker than the current B14. So let's cross out B14, and now I can get rid of that. And the only way to get to F is via D, which is going to be plus D to D20. Now that we've got to the end, we've considered all the paths. You can see circling them all, they're all crossed out, which means I've considered every possible option. And the answer here is we've got to go backwards a little bit. So the final answer is F. We got from F from D. The quickest way to get to D was E, because that's why we had E9 there. The quickest way to get to E was C. And the quickest way to get to C, A2, was A. So our quickest path here, it was from A to C, along to E, back up to D, and then finally finishing off at F. If you wanted to calculate how long that would have been, that related to the 20, and that was 20, whatever the units were, as our quickest path. It might have been minutes, maybe that related to the price to do something, time to run it, whatever it might have been. So we're now on to our next example. Let's say we're over here at Bristol and we want to make our way to London. What's the quickest way to do that? So we're going to go Bristol through to London. Again, we're going to use the algorithm. This one here will be a bit more annoying because there's a few more options to consider, but let's get into it. So let's start off, let's go Bristol to Swindon. So at Swindon, we're going to write B40, and that relates to B for Bristol and 40 for the network there. So we can cross off this edge. Let's go from Bristol to Southampton. So next to Southampton, we're going to write B75. So we've got B75, and that relates to B for Bristol and 75 for the edge. So cross out this here. So we're now at Southampton. Maybe let's make our way over to Swindon, and that there is 70 extra. So that's going to be 75 plus the 70, that's 145. And we're going to go from Southampton. So we're going to write SO for Southampton. So that's SO 145. And you can see there's two different ways to get to Swindon. It was via Southampton, which took 145 minutes, or it was via Bristol, which took 40 minutes. So we'll definitely take the Bristol route if we needed to get to Southampton, so we can get rid of that. Okay, so we'll cross. So we've gone this way, but we can also go down the other way. We could go Swindon to Southampton, and that's going to be the 40 plus the 70. That's 110. So down here, we're going to write SW 110. The quickest way to get to Southampton is definitely that 75 via Bristol. So this option here we wouldn't need, and we've now considered that 70 there. So carrying on up to Reading, the quickest way to get to Southampton was the 75, plusing the 42, that's 117. So we're going to write Southampton SO 117. And I've now considered that 42 there. We also could have gone to Reading via Swindon, and that was the 40 plus the 45, that's 85. So that there is going to be Swindon, so that's SW 85, and that's much quicker than the Southampton route, which would have taken us 117. So I've now considered that pathway there. We're now moving along to Oxford, and that there we had the 40 plus the 30, that gets us to 70, so that's going to be SW70, and I've now considered this route here. I won't really go up that way to Oxford because I know that's going to be longer because we're already at 185 to get to Swindon, whereas it's 170 here, so I won't consider that route. But maybe from Oxford we go down to Reading, which would have been Oxford, and that there would have been 97, pretty close to the 85 via Swindon, but not quite quicker. So let's cross out Oxford, and I've now considered that 27 route. And then finally, let's maybe take this Reading to London route. That was 40. Currently, we're at 85. We're going to add on the 40, which is 125. So we're going to call that R125. So if we go via Reading, it will take us 125 minutes. And we'll then think about going to I should cross this out here. Thinking of that Oxford route, we've got the 60 plus the 70. That's 130. So that there is going to be Oxford 130. And this is where it's a little bit different because there's two ways to get to London, whereas before there was only one way to get into F. We could go via Oxford, which would take 130 minutes. We could go via Reading, which would take 125 minutes. So we're going to cross out Oxford because that takes 5 minutes slower. Now working backwards, so we're at London there. The quickest way to get to London was via Reading. So we want to go via Reading. The quickest way to get to Reading was via SW. So that's SW85, which is Swindon. And the quickest way to get to Swindon was via Bristol. So in yellow there, that maps out the quickest route. Makes sense. It's directly down the middle, which means our quickest route, we go to Bristol, and then we go into Swindon, SW. We're then off to Reading, and then finally we're at London. And the quickest path would have taken 125, and let's just say that related to minutes in this case. So this algorithm was fairly complicated, and it's not for everyone. I definitely get that. In your internal, there is another way to do it, and I'm writing it down the bottom. there is a guess and check method. This option is available for anyone, and this option gets you to consider 3 different journeys. You should pick which ones you think are the quickest, and keep an eye out for a separate video which will run us through how to use a guess and check type approach, and maybe we'll do these 2 examples here to clarify that as well. Thanks so much for watching. Now let's get into heaps and heaps of practice.